Hello friends, my name is Shivam from Devops Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
The first question is why we are here, why we are learning Kubernetes. We are learning Kubernetes because we should get health, our organization should get health, and we both should get happiness. We as an employee and organization as well should get happiness. But in what domain, we will discuss in some time. So the question is, in order to know how you be healthy with this tool, how organization will be wealthy, and how we all get happiness, we need to know what is Kubernetes. What is Kubernetes? We need to know how Kubernetes works, Kubernetes architecture. We need to install Kubernetes, work with the Kubernetes for deployment and many more things. So the question is, how come we get healthy, wealthy and happiness, both of all of us? So let's know about the Kubernetes. In order to know what is Kubernetes, we primarily have to know core information. And the first question is where did it come from? Second question is what does it do? Third question is what does the name mean and why do we have it? So why we are learning Kubernetes? What is Kubernetes? Where it is coming from? Why do we have it? All these things we need to understand. So guys, Kubernetes is born in Google. Yes. Kubernetes is one of the tools which is born in Google. And Google donated to CNCF in 2004 and as part of open source initiative. Now those who are not aware of CNCF, please go to their website, cncf.io. Check it out. And you find it, CNCF is one of the governing body for the open source community and covering large set of applications supported by Google, Microsoft and many other organizations as well. Now, this tool is written in Golang. If you want to access the source code of the Kubernetes, you have a GitHub URL in front of you. You can get it. You want to go to their website like IOs, kubernetes.io. Slack channels are there, meetups, groups are there, and many more things. So this is Kubernetes. But the question is, where does it come from? Where does it come from? Okay. So there is one platform called Borg. There is another platform called Omega. Now, this is the kind of platform which is running Google's right now, Google platform. You see that Google, such a vast platform, which is highly scalable, highly available, highly secured, run by only few people. So you just imagine such a huge infrastructure, what Google has it. They have billions of users base. Crores of people is logged in at each millisecond, and doing something, uploading, downloading, sending an email, searching, or many things they do. And those platforms is running on Borg and Omega. Yes. So I'm not saying Kubernetes is equivalent to Borg and Omega, but because what are the capabilities what we have in the Borg and Omega? Still we are not too much information is in public domain. there are information available in public domain, but not too much information is available in the public domain. But Kubernetes can do something like that. And Kubernetes also comes from Google. So we believe the DNA is matching. So if you would like to know where the Kubernetes is coming from, so yes, it's coming from the same line where the Gog and Omega stands, because parent companies are same. So Kubernetes also can help you to manage your large scale infrastructure, highly scalable, highly reliable, highly secured, highly available. And that's a Kubernetes. And of course, Gog is proprietary, Omega is a proprietary, Kubernetes is open source. Okay. Now, what is the meaning of it? So Kubernetes comes from the Greek word that's called helpsman. What is the definition of helpsman in Greek? So the person who steers a ship, that we call it helpsman. And in English we call it a Kubernetes. So now, what is the meaning of it? So basically, remember, helpsman, the person who steers a ship. The ship size may be one boating ship, one fishing ship, or maybe aircraft carrier, or maybe, some sort of, petroleum ship, which is a very large in size. Correct? So it can be any ship can be any size. It can be smallest and it can be largest, but only one person controls the entire ship. And that we call helpsman. So similar way, if you have a production server, if you have operations in infrastructure running, and it can be very small, 2-node cluster or 2000 node cluster, Kubernetes can manage it. Kubernetes control it. You are not the one. Kubernetes can do that. So Kubernetes can steer your data center operations runtime. Okay. So this is the meaning of Kubernetes. In short, we call it KS. So ultimately, yes, is born in Google, donated to CNCF in 2014, open source. First release has happened 1.0, July 2015, written in Google and other information. Okay. So now, what is Kubernetes? I hope that is answered. But why do we need Kubernetes? That is not answered so far. Right? So, any questions so far, guys? Any questions?
No, you're good.
Okay. So now let's try to understand why do we need Kubernetes. And these are the very important statements that we have. Containers bring scalability challenges. Yes. Containers bring scalability challenges. And we're starting to view the data center as one computer, So what is the meaning of it? Containers bring scalability challenges. So what is this? So let's try to understand it ourselves, because we have covered Docker very well. So we know that what is a container. I hope so. So now understand that there is a one desktop or laptop, one server which holds the containers. Here you have one container, two containers, three containers. Now that's a limitation. This host cannot have more than 3 containers. That's a limitation. Now the containers is managed by Docker. So we have a Docker daemon here. Now what is a Docker? What is a Docker engine? All these things we have discussed. So who manages the container? This Docker manages the container. Now let's say you want to scale for more than 3, maybe 6, 7, 10, 100, 2000. So what you would do? What you would do?
Create the Docker containers manually or automatically and deploy it.
So you will have another host.
Right.
you will have another host where you will have a more container. But I said containers have a scalability challenge. So can you manage this container from this place? Can this can manage the container here?
No.
So we need a Docker here also. Similar way, we need one more host because we have to scale it up. Remember, you are in a production. You have to scale it up. So now we need more. So now you think about it. Docker manage the container. I have said very clearly, Docker is a platform, manage the container. But the question is, who will manage multiple Docker across the server cluster? Who will manage? Think about it. Docker, does that Docker have the capability to manage the multiple container across the server? No. Multiple nodes? No. So who will manage it? Who will manage it? Now, this is the one of the problems which we are trying to solve today. Second problem. Now, let's say this node got disappeared. Now these containers were running, very important containers were running. Suddenly your infrastructure were running on the 9 containers. Just imagine. And suddenly 3 got down. Why? Because the node has some issues. It may be network issues, security issues, hardware issues, software issues. You know that the issues may come from any side, any form. So now, your earlier production was running on 9 containers, but now it's become a 6. That means the experience of the end client has been impacted. So what we should do? We should create alternative container here, here, and here. But the question is, who will do that? Who will manage the desire? Who will manage the desire and actual? If some of the containers gone, automatically it should be replacing with this a new node, a new port, or a new container, whatever it is. So who will manage it? That is missing in Docker. Has no capability to create a container by understanding the containers is missing. You have seen that all of the capabilities of Docker. Okay, so you have seen that. Now next question is, now guys, let's say there is a one load balancer outside. Now I hope you understand each one of you load balancer. Correct? What is a load balancer? How it works and stuff like that. You know that, right? Let me tell you guys one more thing. If anytime if you feel you don't know what I'm talking about, or any terminologies which you are not comfortable with, please do let me know. Because until you ask me, I won't be able to answer. Okay, so I'm not someone who can get your questions when if it is in your heart itself. So please be open. You can ask any questions. So I assume you know the load balancer. Now the load balancer for the client, it will be always front end, right? This is the front end. So now the question is, this load balancer somewhere out of your node. So you tell me, can you access this container? Can you access? Can you access?
Not directly.
Let's say this is Apache. This is also Apache. Okay. Can you access this container?
No.
No. But how can you access it?
Through the host machine.
By port forwarding.
Port forwarding. Now the question is, there's a 2 Apache. You said correctly. There's a 2 Apache. So I will forward the port at this place. That means I can hit to this, and this will redirect the connection to this container. But this time, you know that host has a one network, So let's say 80. What about second container? It's become waste because you cannot expose your 80 again. You have to use 81. And in this case, if you use 81, this load balancer will not work. If you use 80, then you will not be allowed to use 80 because there is one network at a host. So guys, are you able to understand the problem?
Yes, sir.
Yeah. So now the question is how these containers will be available to your load balancer. That is the question. How these containers will be available to load balancer. That is the question. So this implementation is not done by Docker alone. So now I have tried to help you to visualize what are the problems which we have, where we say containers bring scalability challenge. So yes, containers, see a Docker has no capability to manage multi-host container. Docker has no capability to manage if some containers got disappear because of the node problem, they will replace with a new container. Docker has no capability to help you to make this container accessible to the load balancer from where your end users can access it. So what is the solution? Kubernetes is the answer for all these question marks. Okay. Now, there is one more statement. What we are talking about is we are starting to view the data center as one computer. Let's understand in a simple way. Here, you think about it. There is a one host. There is a one host. And this host is powered by so many CPU and so many CPU and multiple RAM. Right? But still, for Docker, everything is one compute, right? One compute unit, correct? For Docker, for kernel, everything is one compute unit, correct? So it's not saying that, okay, this RAM is separate, this RAM is separate, this CPU is separate, this CPU is separate. Getting my point? Getting my point?
Yes.
So for Docker, it's a one computer. So similar way, understand that when we look at the data center, understand that when we look at the data center, there is a one computer, two computer, three computer, 100 computers are there, and there's a compute unit. So now we should check, we should see entire data center compute capability should be viewed as a one. So who will do that? Docker cannot do that. Docker can only check the one host. We have a data center where you are running the containers now. So at data centers, we have a multi-node, multiple servers, multiple virtual machines or multiple physical machines. So now the question is, who will view entire data center as one computer? That is a problem. Who will view that? So now I hope you understand containers bring scalability challenges and why we are starting to view the data center as a one computer. Why? Because containers need to view as a one computer, and all these tools, all these problems can be solved by Kubernetes. So Kubernetes can manage it, all of it. Okay. With that, guys, you have to change your mindset also. So what kind of mindset? See here. First 2 days, we were working with the containers. We were running the containers. We were troubleshooting the containers. We were getting inside the containers. We are coming out of the containers. All the behaviors of containers. If something goes bad with the containers, we were worrying about it. We were checking out, and then we were curious to know why it went wrong. We were working with the images also, and troubleshooting the images, and all these things we did it quite a good amount of time. But now you are not in a container work actually. Now you are running the containers at the large scale. You are not running for your desktop. You are running the containers in a data center. So when you run the containers in a data center, you have to change your mindset. It's all about the pets versus cattle. You have a pet, you love them, you take care of them. If something goes wrong, you treat them, worrying about them. Everything you do it. But once you are in a cattle business, let's say in a cattle business, your goal is to deliver 1,000 liters of milk every day to the end client. It should not be 1,001 liter. It should not be 999 liter. It is 1,000 liters of milk. So now if you have a goal to deliver 1,000 liters of milk every day, and if because of some reason, you think about it, because of some reason, some of the cattle is not performing, your delivery is compromised, what you will do? You will not say to the client saying that, okay, wait, stop, wait for my cattle to recover. Wait for my cattle to recover and then I will deliver the 1,000 liters of milk. What you will do? Immediately, you will replace the cattle with some healthy cattle, and then healthy cattle will start delivering the milk, and then you will deliver to the 1,000 liters of milk to the client. So that is a mindset, right? Let's say your cattle is delivering more than 1,000 liters. So what you will do? You will throw those extra liters of milk which client is not needed. Correct? That is what is happening. Are you getting my point? So here you have to have a mindset of cattle business. Are you getting my point?
Yeah.
This kind of, yeah. You won't trust me. I don't know whether you have watched this video or not. Yesterday night only I was watching one video, and that is on some US news channel. They were having huge production of milk, and the utilizations were not there so much. So they were dumping the good milk to the ground, and potatoes also. Like they were having huge amount of potatoes stored, and the requirement was not there because of the lockdown. So they were dumping in the ground somewhere in the pit holes. I was surprised, like they were wasting so much of milk, there was so much of potatoes, but nothing can be done because they have so much of milk, so much of potato is not being consumed, they don't have a storage, they cannot process it also. So this is something like that. Yeah. So another question is, you have to be in a kind of cattle business mindset. You are in a production. So first 2 days, you were in a development team. You are working with the application, developing images, running the container, testing the containers, everything was okay, fine. Then move on and run that in the production. So now next 3 days, including today, you have to be in production. You have to have a mindset in the production. If some containers is not performing well, no worry. You have to replace the container with some other containers. If node is not performing, you have to replace that. At any cost, the desire has to match. So this is the kind of mindset you have to have it. So ultimately, what is Kubernetes? What is Kubernetes? So in official keywords, we call it Kubernetes is a container orchestrator. What is a container orchestrator? Orchestrator means running the container at a multiple server, not one, but multiple. It may be 2, it may be 5, 10, 20 or 30 or maybe 100, thousands, whatever it is, but container orchestrator. And Kubernetes workload placement tool as well. Workload placement tool, as I said, right, some node got offline because of some reason. So the number of container which was running at that node, they will be placed to other node. Same time, Kubernetes will make sure that which node should be running how much of container. So basically it is taking a responsibility of placing the containers at a node and also redistributing it if it is required. So workload placement, container is your workload, compute unit, running your application. That's your workload. Kubernetes also is an infrastructure abstraction. That means you don't need to know complexity of the system, but it works. Simple. So you as an individual, you don't need to get complicated with that how it works, but it works. So also helps you to abstract the infrastructure, so you don't need to deep dive. And Kubernetes also will make sure that whatever the desire you have, it will be managed by the Kubernetes, not by you. So you set the desire, okay, I want to run 10 containers in my whole cluster. That is the Kubernetes job to run the desired state. I want to run hundreds, not 99, not 101, 100. And that desire will be taken care of by Kubernetes at any stage. So, yep, Kubernetes is a container orchestrator, workload placement, infrastructure abstraction, desired state. Did you understand that what is Kubernetes and why do we need it? Yes. What are the benefits of it? Speed of deployment. See, you want to deploy 2000 containers in hundreds of nodes within a second. Second, I said. You can do that. Ability to absorb change quickly. You want to upgrade that. You want to upgrade the software from V1 to V2, and that should be in a second. Kubernetes can do that. You found out there is a failure, there is a problem in the current release. You want to roll back. That should be done in seconds. Kubernetes can do that. And without you knowing the complexity of the system, basically Kubernetes hides complexity in the cluster itself. You are not knowing what is happening, but your application is up and running. So these are the benefit of using Kubernetes. Same time, Kubernetes is moving very fast. So the only one way to keep up to date yourself with this technology is to keep practicing it. Because today, whatever you are learning may be get outdated after 6 months. So this is one of the best way to keep up to date yourself to use it. Keep using it. With that, we will learn why Kubernetes, how Kubernetes works, what is the architecture of Kubernetes, and so on. So guys, any question?
Yes. So Kubernetes will manage any container framework, right? It's not only for Docker, right?
No. Kubernetes supports many container interface projects, including Docker. Docker is the default one.
Okay. How this is kind of linked, I mean, so it was released on 2014, right? So it's kind of separate entity, separate thing.
See here, Kubernetes is an orchestrator tool. Okay, orchestrator tool for the container. How it orchestrates the containers, that's the questions which will be answered in this session. How Kubernetes works. Okay, that's the reason I'm saying you need to spend entire half day with me so you understand how it manages. But yes, just to answer your question, Kubernetes supports Docker, Rockets, Containerd, Postman, and many more containers engine, container runtime. But how it supports, you need to understand. You need to be with me for some more time.
Okay.
Okay, guys. So now let's understand the Kubernetes architecture. So we will learn what is master, what is a nodes, what is a pod, what is the services, what is the deployments, and many more. So let's understand the Kubernetes at a big picture. So Kubernetes is an orchestrator of microservice apps. Yes, Kubernetes is an orchestrator for microservice apps. See here, in the last session I said Kubernetes is an orchestrator for containers. But now I'm saying Kubernetes is also an orchestrator for microservices app. And I assume you know what is a microservices concept. With that, let's discuss about it.
To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely.
Here, there is a football ground, there is a team, there is a manager, coach. So let's say all these players are having to play here on the ground, and if these teams are playing without a direction, understand that. If each and every members of the team is playing without a direction and they have only one objective, and I know that you probably say objective is to make a goal. So if they have a goal, each and every member have a goal to make a goal. If each and every team member of is having objective to make a goal, then they will play like this. Everyone will be next to the goal post. But that's not how you're going to play. That is where you get manager. Manager comes, manager, aka coach, aka master. So this guy comes and say, listen, each one of you will do only what I say. If you do not follow me, if you do not obey me, I will pluck you out of the ground. Okay, I will take you out of the ground. So now every player starts playing, and manager knows each one of their capabilities. Someone is very good in defense, someone is good in attack. So now their job is not to make a goal. Their objective is not to make a goal, just to coordinate. You should not run more, but let's keep balls running, football running. Okay, and that is how there were one or two players at the near to the goal post. They will make a goal. So this is how the teams play, with the help of manager and coach. So manager is very important, because without a manager, without a coach, these players will become a meaningless, directionless. Objective will not be met. So if you look at this in the world of Kubernetes, you have a different kind of containers, and holding the responsibility is also different kind. For example, HTTP, search, KB store, log, load balancer, MySQL, this, that, and all. So different kind of microservices you are running in the Kubernetes cluster, or outside also. Even though it was not you were not having Kubernetes, before that also you were running the Kubernetes microservices. So each microservices has, these are the microservices, guys. So each microservices is having certain roles to play, certain direction to play, certain communications to be happen. Now someone will talk to someone will not talk to someone, like that. Okay. So here, these are the microservices, and between the microservices, there is a contract. Now the interesting thing is, see here, who should talk to which one? Who will manage? Kubernetes. Interesting thing is also here, look at this here. HTTP is node 1 and HTTP is node 2. So here, irrespective of your service, microservice, which node they are running on, the behavior will be same. Behavior would be same. So who's doing it? So this is done by microservices. Microservices is your manager, Kubernetes. So Kubernetes is your manager, coach, master, which is orchestrating microservices. That's the reason we call it Kubernetes is an microservices orchestrator tool. Okay. We will understand what is a microservices when we get into the demo part of the Kubernetes. So that's a good topic. So ultimately, let's talk about the Kubernetes architecture. So in Kubernetes architecture, we have a Kubernetes cluster. We call it KS cluster. If you look at this image, in the KS cluster, we have a master, and you may have a multiple master also for HA. And here you have a nodes, aka minion. Okay, so you have a multiple node, and this is called cluster. Now, someone is giving the package, deploying the package to the master, and that's the package extreme left side. You see that's the package. Okay, so in the Kubernetes cluster, if you talk about architecture, you have a master, you have a node, you may have a multiple master. So master is who's in charge of managing entire node, and the node is the node who's doing the real work. That means node is the place where you are running the containers, real work, do the work. Okay, in charge. So now you see here the package which I was talking about. We typically very often call it deployment package. We send this deployment package to master. And master who's in charge, who manages all the nodes, who's doing the work. Node has a pod. Look at this very carefully. Node has a pod. Now the question is, what is a pod? I don't know. But inside a node, you see there is a container image. Inside a pod, inside a node, you have a pod, and inside a pod, you have a container. Okay. So here, what is a pod? So far, I don't know. I have not explained it to you. But container we know very well. We have spent 2 days on it. Okay. So now master. So we send the deployment package to master. And master, with the help of node, do the real work. So node who do the real work. Inside a node, we have a pod. And inside a pod, we have a container, which we know very well. So this is the more or less architecture. What is a pod? I need to explain it to you. So now let's deep dive into the what is master in detail. Okay. So masters, we also call it Kubernetes control plane. So whatever you want to call it, master or Kubernetes control plane, as per your comfort level. Okay. In the documentations, most of the time you find control plane. And so when you read the control plane, you consider this as a master. The role is master, playing a role of master. We call it control plane. See here, master, which has to be in a Linux, okay, 64-bit, and master manages a multiple node. Node is in Linux, but from the new release, from last 1 year release, you can keep it Windows also, Windows 2019 plus, I think. So, but in our sessions, we'll only cover the Linux, not on Windows. So yes, here node is in Linux, or it can be Windows, but master has to be in a Linux. That's called Kubernetes master, Kubernetes node. Now, master has 4 important components. Master has 4 important components. Master can be HA for high availability. Let's say, because master is very important, remember, master, if you get missing, then your teams will not play. Teams means microservices will not play as per the meeting up the objectives. So master is very important. So it has to be HA. If one master is not responding, you have a second master or a third master, like that. Master has a 4 component. Master manages the nodes. Look at this here very carefully. Node has pod, and pod has a container. Pod may have a multi-containers also, and a node you may have a multi-pod also. Look at this. Node have a pod. You may have a one pod. You may have a multi-pod. Pod has a container. Each pod may have a one container. Pod may have a multi-containers also. Look at this very carefully. And master has a 4 important component. Okay. So let's focus on the master. So first component of master, we call it API server. Now what is API server? Now what is API server? So can you please read this? API server, which is a front end to the control plane, exposes the REST APIs, API REST, and consume JSON. Okay. So what is this? Please read it.
Maybe this is the entry point where we give the set of rules, authorization.
Something like that. So you understand about the API, right? Do you understand
Yes.
the API?
Yes.
See, think about it. This is a master server. In the master server, there are so many features are available. Feature 1, 2, 3, 4, 5, 6, 6, 7. Now, these features are available, and if you want to access this feature through the remote server, through the IP address, then you need a REST API. So here, you think about it. You will reach to this feature, and here you have exposed the API at API. So if you expose that API, think about it. If you expose that different API, then let's say you expose with 80, this one, 80 port, 81 port, 82 port, 83 port, 84 port, 85 port, and 86. Now only you have a 3 3 just 6 and 1 7 port, and you got a 7 services, 7 feature API which got exposed, and you got frustrated, saying that what I'm doing, 1 2 3 4 5 6, what I'm doing. Yes, of course you will get frustrated, because Kubernetes has 50 plus API feature. More than that, I have not got exact count, because every week it is increasing. So just imagine, do you remember 50 port? Think about it. Tell me, do you would like to remember the 50 port for different features for API? What do you think? No, of course not. So what you will do? You will create a registry. Have it every API registered at this place. Okay? And you will have only one port. Let's say some 2x, some port. Okay? So this is a software which its job is to manage multiple APIs and make it available at one port. And this registry is called API server. Okay, I hope you are getting my point. This is a server for what? API. So if you want to explore all these features, you have to talk to API server and get that feature up and running. Now, in the API, what you will do? Most of the time, you will do the CRUD operation. Each API, what you will do? CRUD operation. Create, read, update, delete. Create, read, update, delete. Create, read, update, delete. So using one endpoint itself, you can consume every feature, whatever you have. Are you understanding my point? Are you understanding my point?
Yes, Rajesh.
Yes. So guys, this is the API server. Don't think it's the one API. There's a difference between API and server. It is the API server which has a multiple API. It's a registry. Registry, you understand, right? A place where you have so many. Like you have used Docker registry. So many repositories. Of what? Docker image. You have a GitHub registry. So many repositories of what? Source code, Git. So here API server is also kind of registry which has so many APIs at one place. So you won't get lost. So yes, it is of course because API you know that consumes JSON all the time. And API, REST API, content to the control panel. That means, remember, if you want to send any communication to master, because master control entire infrastructure, entire Kubernetes cluster, if you want to send anything to the cluster, you have to send to the API. It is a front end. It is a front end. By the way, let me tell you here guys, this I said 50, probably might not be true because this 50 is only for the human beings. Internally, they have also lots of features internally they have implemented, hundreds or hundreds. All that can be accessible by API service. Okay, so we can list out those services when I show you the demo. First, let's understand the conceptual. Okay, so did you understand the API server? Any questions? Any doubts?
Rajesh, these APIs are the ones provided by Kubernetes or our API?
No. I'm not at all talking about your API, my API. I'm only talking about the Kubernetes API. That means you want to access the feature of Kubernetes for that API server. That's all you need to remember. If you know API server and name of the API which you want to use it, send to API server, you will get that feature. That's all. I'm not talking about your software, my product, your software, your product, like that. Okay?
Yes, sure.
Just give me a few seconds. Okay. So, now next one is, I would like to see one face. So I can explain you very easily. So let's go to the Google. Face tick. See here. Let's take this image. Okay. Now, okay. So if you want to tell me what is the API server in this particular functionality, I mean, let's see this as a face, but consider as a control plane. Control plane means master. This is your control plane of your body. In body, there's so many functionalities are there, like a hand, leg, hand also moves, legs also do something. You have an abdomen, so many components you have in the body, which is controlled by this place. So tell me, what is the API server here? It can be?
Brains.
No, API server.
Blink.
Okay.
Eyes.
Correct, no?
Eyes.
Here. Now, you input, you front end, I mean, you input from the eyes. Ears, not eyes. Ears. You hear something. Let's say if I ask you, do something. So you first hear it. And then what you do after this? What you do after this?
Processor.
Store it, no? Store it. Storage, correct? You memorize it. Store it. So if I ask you, you do something. So you listen and then store it in your memory. Correct? And then you respond it from your response. This is a request. This is a response. Correct now? Are you getting my points? And how do you monitor it?
Yes.
This is the 4. So 1, 2, 3, 4. Correct? This is a master. Everything you do, you have a functionality so your body has a multiple functionality which you did get it done. So like this. So now something similar concept we have in the master also. Look at this. Now you have received some input, okay, some request. So you need a storage also. So please read this. See here, API server, look at the arrow sign. It immediately stores something. Where is store? Cluster store. So what is cluster store? Cluster store is your persistent storage. Yes. Whatever you receive, you store it for permanent. Okay. So whatever you receive, you store for the permanent. So this is the persistent storage. Now what it stores, that's important. So basically store the cluster configuration and state file whatever you receive from the outside or inside. Okay. Now the question is how the storage is happening. Is it happening in MySQL? No. It is using etcd, which is a distributed, consistent and watchable sort of way to store the information in a form of keys and values. Okay. Keys and value. So etc is a kind of tool which has been used for storing, which is a persistent storage, consistent, watchable. Now, so basically this is a source of truth. For example, your mind is, so if I want to tell you where is your characteristics stored about you? So you say in your mind. So something similar in etcd, it is a source of truth for the cluster. That means if something is not exist in your etcd, that means that is not exist in your cluster also. Okay. And you have a backup plan. You should be having a backup plan for it. So guys, did you understand the cluster store? Did you understand the cluster store?
Yeah.
Yeah. Something similar to our mind. Okay.
So one question.
Yes.
So when it says it uses the persistent storage, it uses the hard drive space itself?
It uses hard drive. Yeah, of course. Yes. Of course.
Okay. So it's permanent. Okay.
Yeah. And again, I would request you to read more about etcd. Do you know Elasticsearch?
Yes, but I don't know how it works.
Okay. Yeah. So something like that, it stores that information, or Mongo, something like that key and value they store it. No SQL. So something like that, etc is one of the tools for the storing the keys and value based database information, which can be distributed. Distributed means this etcd can run in the multi-node cluster. Consistent means it can replicate to each other, and watchable, that means any node you can watch. It's not like you need a server for it. So this is a very good way to store the data, but here it's being stored in the etcd. Okay. Now third point is controller manager. See here, there's a please whenever you read any keywords, right? Please try to break it down. There is a two word, controller, and second word, manager. So not a controller, only manager of controller. So this tool is a manager of controller. Now the question is, what is controller? So look at this, what is a controller? See here, your eye is a controller, okay, which is keep updating, is keep watching the whole world and keep informing to your memory, correct? Saying that, okay, this I have seen it, this I have experienced it, whether it's good or not good, whether it's the whatever the state, real state, your eyes will keep watching and then updating to your memory, and memory will also getting updated from the controller. Are you getting a point?
Yes.
Yeah. So something like this we have here. But you see here, so controller is basically control everything. For example, it monitor entire infrastructure like a node. Are you available? Are you available? Are you available? Endpoint, namespace, and many things is control. That means entire infrastructure, entire cluster is being controlled by controllers. And there is not one controller. Understand that. There is a multiple controllers. And here, I'm not talking about the controller. Here in the picture you have a controller, but actually that's a controller manager. Okay. So controller manager has a multiple controllers, and each controller control one thing and keep updating to API server. An API server, whatever the information it gets from the controller, it keep storing in the cluster store, because API server is only the front end which can communicate with the cluster store. So here, if you can consider this as a monitoring tool which keep watching each and everything. Let's say one node got offline, it will report back to the API server. If one containers got offline, it will report back to the anything good, anything bad, anything not good, anything not bad, everything it controls. And then keep updating API server, which internally keeps in the API cluster store. Are you getting my point here?
Yes.
Okay. So guys,
So basically everything is as one human interaction, or
Rajesh, your voice is breaking.
inside the control interaction it happens through API server, like the controller directly go ahead and store something.
no, there is no human interaction required, because I told you initially only, you are doing nothing, everything will be done by the Kubernetes. And I'm teaching you how can Kubernetes can replace you. Everything will be done by Kubernetes, not by you.
Okay.
Okay. Okay guys, so let's move on. I hope you are getting. Fourth, and by the way, controllers works in the loop. That means if the controller is not running, that means your cluster is not in healthy state. So it always run in the loop. For example, it will keep asking each node, are you available? Are you available? Are you available? And the node has to respond, yes, I am available. Yes, I am available. Like that. If anyone who's not responding, immediately controller manager will inform that to API server saying that this guy is not available. Let's do something. Okay. Or let's say this guy also manages the desired state. For example, you said to Kubernetes create 20 container of Apache, and suddenly from 20 it become a 19. So controller is checking, okay, 20. Suddenly it become a 19, immediately it will respond back to the API server, and API server will do the necessary action. Now guys, next component is kube scheduler. Okay, kube scheduler. Now the question is, what is a kube scheduler?
Rajesh, one quick question on the controller.
Yeah.
So the job of the controller is controller manager is only to check the availability of the container?
No, controller manager manages multiple controller. Read my line. Controller manager manages the multiple controller, and each controller will check one thing, and that thing in a loop. And controller manager will inform that to API server.
Okay, so the controller is only going to check about the availability.
Not only, I'm saying, that's what I am. Please read my line. Controller manager will check different kind of, will manage different kind of controller. And each controller manages different kind of things.
Okay.
There is a one controller for every monitoring. Every kind of monitoring.
Okay.
Like a node monitoring, like a node controller, endpoint controller, namespace controller, desire controller, many controllers are there in that. So in a nutshell, whatever you wanted, it will manage and control it. If something mismatched, it will report back to API server, and complete his work.
To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely.
Okay, sure. Got it.
Now, next and last component is of the master is called kube scheduler. Now the question is, what is a kube scheduler? So guys, kube scheduler is basically scheduling the work. Understand that. See here, scheduling the work. If you look at the face here, this is a scheduler. This is a controller. This is a cluster store, and this is the API server. Scheduler will schedule. Let me tell you, it's not doing the task, it's just scheduling it. Scheduling it, not doing the task. Okay? So just scheduling it. Are you getting my point?
Yes.
So please read this slide first and then I'll explain you in detail. Okay? So basically what happens, see here. Human sends some request to API server. API server stores that request to cluster store. Controllers check that request, what is the status. And API server send the scheduler saying that, okay, do one thing. You create these many pods. Now the question is, what is a pod? We don't know. So I have not explained you, but one thing we know, pod is there in the node. And inside the pod you have a container. That we know that. But what is a pod? We don't know. So here scheduler watches the API server for new pod. That means scheduler keep watching the API server for request. Is there any request for me? Is there any work for me? And based on the work, what happens? Scheduler gets the request and assign work, not do the work. Remember, doing the work is done by nodes. Understand that. It assigns work to the node. And now, scheduler has affinity and anti-affinity. What is affinity and anti-affinity? When you, by default it's anti-affinity. So anti-affinity means scheduler will assign the work to any nodes who's available and healthy. But when you have affinity, then it will assign only to the work to the specific node. Okay? Specific node. Scheduler can have a constraint also. That means it can assign the work based on the constraint. That means this much of RAM should be available, or this operating system, or something like that, and resources. So that kind of constraint is set by scheduler, and based on that it assigns the work. So overall, this is called master. This is called master, and this is the sum up of it. So understand that master, akka, control panel, these are the four components we have. Four components: API server, cluster store, scheduler, controller, manager. So API server is the central, simple, restful, and updated etcd. Cluster store is persistent state, key value, etcd, powered and watchable. Scheduler watches the API server, schedule the pod, resources, some constraint also. Controller manager always controllers loop. Lifecycle function and desired state, it watches and updates the API server and replica set. What is a replica set? I'll come back to that. So these are the things. Did you understand that everything, guys?
Yes.
Yeah.
Rajesh, one question. Do we run any containers in master?
This question, I shall answer this one later. Okay. During the demo time, post line.
Okay.
But just to calm your questions, yes or no. Why I said yes and why I said no, you have to wait for it. Both the things I said possibly.
Okay. Yeah, okay.
So guys, ultimately, this is architecture. So here you see master, node, and in your workstation, you have a kubectl. So who can communicate with the API server? Kubectl. Where it is? Kubectl, it's in your laptop. So how you communicate the packages? You create a JSON packages, YAML packages, but API server always consume JSON. So you send that command to your packages, deploy the packages to API server, and from API server, everything gets stored in the cluster store, and controller is controlling through the different controllers. They control monitor entire infrastructure, cluster, and keep updating API server based on the API server controller. API server do take up a call based on the reports received from the controller and storage, which is done in the cluster store, and scheduler take the request from the API server, and scheduler assign the work to the node, and the node has some more components also which I have not discussed so far, but node has a pod has a container, which I know that. So we'll discuss. This is a big picture of architecture. This is how it is happening. So are you comfortable with the masters and their components?
Yes. Sure.
Okay. So now I'm going to discuss about node. Okay. So what is a node? Aka minions. What is a nodes? Aka minions. The Kubernetes workers. So yes, there are many names actually. You can call it node. You can call it minions. You can call it worker. By the way, guys, have you watched this movie called Minions? Anyone?
Yes.
Okay. So how many of you watch? I mean, anyone else also? Only you or someone else also?
I didn't get the question. What is that?
So there's one movie called Minions. Have you watched this movie?
Oh, yeah. Yes.
Okay. So tell me the story of this movie.
They'll be searching for the boss.
Yes. So can you put it?
Minions was actually the next part. There was a previous part of the Minions. There's a movie. I don't recall the name actually.
Okay. Anyone would like to share the story in 2 minutes? Okay. No. So I think you should watch this movie. It's a very good animated movie. Good for kids also. So let me tell you the story. One fine morning, Minions gets up and please focus on each of my lines. It has some relationship. So one fine morning, Minions gets up and they become sad. They become sad. Why? Because they cannot survive without a master, and they have no master. So minions need masters. No master means sad. No work. Simple. No work, that means I'm sad. So minions look for the master, and they travel whole world to look for the master. This is story actually, very exciting story. They travel throughout the different ways to find out the master. And they found out the master. Okay. They found out the master. And then minions become happy. And the moment minions find out the master, they become so much happy that they keep bugging the master, saying, "The master, I'm available, I'm alive, I'm having so much of energy. Please give me the work, give me the work, give me the work." But masters will give the work only once he is having it. But minions, by habit, they'll keep bugging it to the master. So, by the way, let me ask you one question. What is there in the master who assigns the work to the node?
Scheduler.
Yes, scheduler, yes. Good. So yes, minion will keep bugging it, the master. In the movie, there is some, different scenes also, like by mistake they kill the master, this, that and all happen, and then again became sad. Again they started finding out the master journey, this, that and all. Very exciting story. But overall, what I'm trying to tell you here is, minions' life is meaningless without a master. The moment they look for the master, they get up. look for the master. The master is not available, they become a sad. So they travel the whole world to find out the master. They find out the master, they keep bugging master. And they listen the master. So master, whatever they say, minion has to perform without if and but. Okay, if and else, whatever it is. Okay, so this is the story of master. So guys, same story applied to the nodes, aka the Kubernetes worker as well. Okay, Kubernetes worker as well. So now the question is, what is a node? What is a Kubernetes worker? What are the components? How it works? And everything.
Please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.